Next, exponent rule, quotient of powers. Again, before I tell you the rule, we're going to look at some examples of quotient of powers. Where by quotient of powers, I mean I'm dividing two powers. First example, n to the fifth divided by n squared. To write this in expanded form, I'm going to write the numerator in expanded form, n times n times n times n times n. And then the denominator in expanded form, n squared is n times n. To find the simplified form of this quotient, I'm going to look for all the pairs of n in the numerator and the denominator. I'm going to cross those out. So this pair, n divided by n, I can cross out because n divided by n is just 1. Second pair, n divided by n, also 1. That leaves me with n times n times n to the third power. Next example, I have a coefficient in the numerator. That doesn't change much. I just have 7 times a to the 8th, a times 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 a. 8 factors of a. Oh my gosh. Divided by a to the 6th. A times a times a times a times a times a. Here there's only one coefficient of 7 and it just stays put. Again, I'm looking for pairs of a in the numerator and denominator because those I can cross out. They equal 1. A divided by a, 1. A divided by a, 1. A divided by a, 1. It's kind of fun. A divided by a, 1. 1. 1. That leaves me with just 7 times a, which is a squared. I don't write a dot in between those. That's what a coefficient is. I'm multiplying it by that power, 7 times a squared. This says when there is a coefficient in front of one of the powers, the coefficient stays in the numerator or the denominator. If this would have been a to the 8th divided by 7, a to the 6th, my final simplified form would be a squared over 7, which I could also write as 1/7 a squared. But we usually just write it as a squared divided by 7, a squared over 7. Next example. Now I have a coefficient in the numerator, 3, times u times u times u times u times u. That's u to the 5th, divided by 12 times u to the 4th. Now I have 4 factors of u times u times u times u. Looking for numerator-denominator factor pairs, that's 1, that's 1. U divided by u1, u divided by u1. I'm just left with 1u. Now I'm not going to write 3u over 12. What I'm going to do is simplify this fraction. So here I have a common factor of 3. Common factor of 3. So I can simplify this. Divide by 3, 1. Divide by 3, 4. I can simplify that fraction 3/12 to be 1/4. That means my simplified form of my quotient, I don't want to write that 1. It's not very sophisticated, but it's not wrong. So I could write 1u over 4. It's what I was talking about above. Some students like to write this as 1/4 u, but I'd really recommend u divided by 4 like this. It is a really, really common mistake for students to just divide the bigger number by the smaller number, so to simplify this as 4u. So just make sure you don't do that. 3/12 is not the same as 4, but it is the same as 1/4. Have you noticed the quotient of powers rule from these examples? Where are we getting the n to the 3rd from n to the 5th divided by n squared? Where are we getting the a squared from a to the 8th divided by a to the 6th? Where are we getting the single u, so a u to the invisible 1, from u to the 5th divided by u to the 4th? Do you see the rule? The rule is when we are dividing powers with the same base. Again, you can only use this rule if the powers have the same base. Keep the base the same and subtract the exponents. Subtract the exponents. So here we did 5 minus 2, which is 3, 8 minus 6, which is 2, and 5 minus 4, which is 1, which we don't write with a 1. We have an invisible exponent of 1. Again, I would like you to be able to just use this rule, have it memorized, be completely comfortable with it. But the expanded form is super helpful for helping you understand where the rule comes from. I have 5 factors of n in the numerator, 2 factors in the denominator. I cross out 2 of those factors, so what I'm left with is n to the third. Here, 8 factors in the numerator, 6 in the denominator. I'm able to cross out 6 of those pairs, and I'm left with a squared. Again, when we're dividing powers, when we're taking the quotient of powers, you keep the base the same, and you subtract the exponents.